Okay, question 8 from paper 1 from DBE from November 2021 past exam. So this question is on electric circuit. Okay, so this is the question 8 on electric circuit. The battery in the circuit shown below has an EMF of 12 volts and an unknown internal resistance lowercase r. The resistance of the connecting wires and diameter is negligible. Okay, so you are given the following circuit. Now, switch S is open. 8.1. Write down the reading on 8.1.1. Write down the reading on voltmeter V1. 1 mark. Okay, voltmeter V1 is connected across the battery. Okay, across the battery. Okay, you can see. So no current is flowing in the circuit when switch S is open. Okay, when no current is flowing in the circuit, switch S is the main switch. Okay, you can see the current coming from the battery. The current will not flow when switch S is open. Okay, so switch S is the main switch. So when no current is flowing in the circuit, with your voltmeter across the battery, you are going to read the EMF of the battery. So V1 will read 12 volts. Now 8.1.2, write down the reading on voltmeter V2. 1 mark. Okay, voltmeter V2 is connected across the 6 ohms resistor. Okay, so because no current is flowing in the circuit, you don't have current flowing through the 6 ohms resistor. Okay, so the voltmeter V2 will read 0 because no current is flowing. Okay, you have switch S is open, so no current flowing in the circuit. Now switch S is now closed. Okay, switch S is now closed. Okay, the reading on diameter is 1.2 amperes and the power dissipated in resistor X. Okay, resistor X is 5.76. Question 8.2. Define the term power. 2 marks. So the power is the rate at which work is done or energy is transferred. Okay, so from the formula, you have to see that power is equal to the work over change in time or energy over change in time. Okay, whenever you have the word rate, you have to understand it is division by time. Okay, whenever you have the word rate, it is division by time. So this is the definition of power. So the definition matches with the formula. Now question 8.3. Calculate the resistance of resistor X. So to calculate the resistance of resistor X, you can see you are given the power. Okay, you are given the power and you also know, let me show you, when switch S is closed, you are going to have the total current flowing through resistor X. Okay, so from the battery, you can see when the switch is closed, okay, diameter will read the total current, okay, diameter will read the total current. You are going to have the current will divide at this node, okay. Some of the current will flow through this resistor and some of the current will flow through this resistor and then after that through this resistor. Okay, so you can see the 2.4 and this 6 ohms resistor, they are connected in series. Okay, so the current will join at this node. Now you have the total current again. Okay, so you are going to have the total current flowing through resistor X. Okay, so you have 1.2 flowing through resistor X. Okay, now you have the power and you have the current. So using the formula for power, you are requested to find resistance of resistor X. So you know the current and you know the power. Can you see this formula can be useful? So we are going to use this formula. Okay. Okay, we have the power, we have the current. So you have the power, which is equal to current squared times resistance. You can divide by this on both sides so that you can solve for R. Okay. Okay. This is equal to okay, you have 4. Okay, 4 ohms. So this is a 4 ohms resistor. Okay. So this is how you can solve question 8.3. Let's move on. Now, question 8.4. Okay, 8.4. This is the question. Okay, so now you are told switch S is now closed. Okay, switch S is now closed. Okay, now we have to calculate 8.4. Okay, calculate the total external resistance of the circuit. Remarks. Okay, the total external. Okay, external. So we are going to look at these resistors which are outside of the battery. Okay, outside of the battery, not internal. Okay, only external, outside of the battery. So question 8.4 calculates the total external resistance of the circuit. So let me show you. You have the switch is closed. Okay, switch S is closed. Now you have the current coming from the battery. Okay, flowing through diameter. At this node, the current is going to divide. Okay, so some of the current will flow through the 6 ohms resistor and some of the current will flow through this 6 ohms resistor, and then after that the same current will flow through the 2.4 ohms resistor, and then the current will join at this node. Okay, and then now you have the total current flowing through resistor X, okay, back to the battery. So can you see this resistor and this resistor are connected in series? We have to find the total external resistance of the circuit. So let's find for the series combination first. Okay, so for the series combination, okay, RS, for the series combination, this is equal to, you have 6 ohms plus 2.4 ohms. You are going to have 8.4 ohms. Now, can you see? You have a parallel connection. Okay, you have this resistor is in parallel with this combination. Okay, with this combination, you have the current is dividing at this node and then joining at this node. Okay, let's calculate for the parallel connection. Okay, so for the parallel connection, you have 1 over Rp. Rp for resistance in parallel. This is equal to 1 over 8.4. Okay, 8.4 plus 1 over 6. Okay, you can use your calculator. Okay, you have 1 over 8.4 plus 1 over 6. You have 2 over 7. Okay, you need Rp, not 1 over Rp. You need Rp. You are going to flip. So you are going to have 7 over 2. Okay, 7 over 2 ohms, which is equal to 3.5 ohms. Okay, now you have for the parallel connection. Okay, so you have this combination. Okay, this combination in series with resistor X, which is equal to 4 ohms. Okay, we calculated for resistor X in question 8.3. Okay, so you have 4 ohms. Okay, so now for the external resistance, this is equal to, you have 3.5 plus 4. Okay, you have 7.5 ohms. Okay, so we are done with question 8.4. Now, question 8.5, calculate the reading on voltmeter V2. V2 is connected across the 6 ohms resistor. Okay, V2 is connected across this resistor. Okay, so we have to find the voltage across this resistor. Okay, we have to find the potential difference across this resistor. Okay, so you can use this formula. Okay, remember this formula. So you need the current through the 6 ohms resistor and you need the resistance. Okay, you have the resistance which is equal to 6 ohms. Okay, you need the current. After you have the current, now you can find the voltage. So we have V2. Okay, V2 is equal to, we need the current through the 6 ohms resistor times the resistance of the 6 ohms resistor. Okay, so we can find V2. So note that the current through the 6 ohms resistor is equal to the current through the 2.4 ohms resistor. Okay, because they are connected in series. Okay, so you have the same current flowing through. Okay, because they are connected in series. Okay, you also have to know that this combination, okay, the combination R6 ohms and R2.4 ohms, okay, this resistor and this resistor, this combination is in parallel with this, okay. So you have to see that because you have the current dividing at this node and then joining at this node back to the battery. So you have a total of 1.2 amperes will come and then divide and then join back to the battery. So we have to find the current through this combination, through the 8.4, okay, 8.4. Okay, you have 8.4. So you have the same current on this branch. So to find the current flowing on this branch, okay, this is equal to, you have the total current, okay, you have a total of 1.2 amperes going into the parallel circuit, okay. Obviously, when the switch is closed, okay, when the switch is closed, okay, so you are going to have 1.2 times. Now you are calculating the current on this branch. On this branch you have 8.4, so you are going to have 1 over 8.4 over, now you have this branch 1 over 8.4 plus this branch 1 over 6, okay. On this branch you have 8.4, on this branch you have 6, okay. So if you don't know how to use the current division rule formula, please check the link in the video description about current division rule formula, okay. So this is equal to, let's use the calculator. So 1.2 times, you have 1 over 8.4. Now 1 over 8.4 plus 1 over 6, okay, you have 0.5, okay, 0.5 amperes. So this is the current flowing through this branch. The remaining of the current will flow through this branch, okay. You have 0.5 on this branch and the remaining of 1.2 will flow on this branch, okay. The remaining is 1.2 minus 0.5, okay. You have 0.7 flowing on this branch, 0.5 on this branch, okay. So please check the link in the video description about current division rule formula. So now we have the current and we have the resistance. Now we can calculate V2, okay. So let me do this. Now V2 is equal to, you have the current times you have the resistance, which is 6. This is equal to 3 volts. Now question 8.6, okay, 8.6. Let's get the question again. This one, okay. Now question 8.6. You are told a length of wire of negligible resistance is used to connect point P to point Q in the circuit, okay. They use a wire to connect point P to point Q, point P to point Q, okay, like this. Now, how will the reading on voltmeter V1 be affected? Choose from increases, decreases, or no effect. Explain the answer. 4 marks. Okay. Can you see? You are creating another path. This is the same way as creating another branch. Okay. So you are decreasing the resistance. Remember, in parallel, you are decreasing the resistance. Okay. You are creating another branch. This is creating a parallel connection. You have this branch and another branch. Okay. You are going to decrease the resistance. The resistance is decreasing. So V1 will decrease. Okay. So now the total external resistance will decrease because you are connecting in parallel. So the total resistance decreases while the current increases. Okay. When the resistance is decreasing, the current is increasing. So this is affected much by the resistance. Okay. So V decreases. Okay. The reading on voltmeter V1 decreases. Okay. Because you have the total resistance of the circuit is decreasing while the current is increasing. As a result, the external voltage, okay, the external voltage, what is supplied outside of the battery will decrease because the resistance is decreasing. The external voltage will decrease. Okay, remember, external voltage is calculated using this formula. External voltage is equal to current times external resistance. So when the external resistance is decreasing, the external voltage will also decrease while the current is increasing. So the current will always do the opposite. Okay? And the internal voltage will always do the opposite of the external voltage. Okay? So remember, the EMF is always constant, and we are going to assume the internal resistance is always constant. Okay? For now, we are done.